sold and you could waste around $500 million. So it's a very pricey business to be in. But where it all starts is if you were to say work at a pharmaceutical industry, you would be part of a team that wanted to target a specific disease. And so there is the metabolic disorder team, there's the respiratory team, there's a cardiac team, and you'd be assigned on a team that would want to target a specific disease and specifically target maybe a pathway, a metabolic pathway that you would go about trying to cure this disease. And in doing so, you want to synthesize a large variety of molecules that you think would affect that pathway and help cure the disorder. So you start off making a bunch of molecules and you subject them to that high throughput screen, which I was telling you about before. So once you have around 10,000 molecules, you shoot it on the robot. The robot puts out a readout, and you can see if you have any good quote-unquote hits or a molecule that might become a good drug in the future. And so once you have a hit, you need to make sure it's not toxic. So then it goes on to animal studies. And from there, if it's not toxic, then it goes on to organic chemists. And then the organic chemists are to formulate the drug to make it more market ready. So they can change different groups on it to make it metabolize faster. They can make different groups so that it dissolves in your body more readily. And they also want to make sure that it doesn't have any unwanted side effects as well. So once you have a good candidate, it's going to go on to trials, phase 1, phase 2, and lastly phase 3. So phase 1 trials are given, the drug is going to be given to a healthy population of, a small population of healthy people. And if no one gets sick from it, then it goes on to phase 2. And phase 2 is a small sample size of sick people. And then lastly, phase 3 is a very large sample size of sick people. And so throughout this process, if everyone is okay and the drug seems to be doing what it should, it goes on to government agencies and it gets approved as being a new pharmaceutical. But as I was saying, any step along here, if people get sick in phase 1, the drug is killed. And so the drug needs to be successful all the way through. And so a lot is riding on a drug candidate right there. And I obtained my bachelor's in chemistry in addition to a math minor. So the reason for the math minor is that, as I said before, physical chemistry involves a lot of math. And so in order to be a chemistry major, you need to go through physical chemistry and you need to understand a lot of math. And so I had to take up to Calculus 3 in order for me to complete some of these chemistry classes. But here are some of the classes that I took. I took a full semester of organic, a semester of analytical chemistry, a full year of physical, inorganic chemistry, advanced organic, instrumental analysis, and then lastly a chemistry seminar. So chemistry seminar is kind of what I'm doing today. I had to present a topic on chemistry to my chemistry department, and you get evaluated, and it's good practice for you to learn how to speak in public. So this is kind of the general course curriculum for earning your undergraduate degree in chemistry. So in the back, I brought University of Michigan curriculum. So if you're interested in a bachelor's in science from the University of Michigan, that's probably going to mirror a lot of what I took, but it's in the back if you're curious. So undergraduate research was something that I wasn't even sure of. I think my dad's friend was like, you should do research. I'm like, what's that? I had no idea what he was talking about. And so, but once I looked into it more, I realized that's something that I kind of wanted to do. And so with undergraduate research, you investigate a real problem that you have no idea how it's going to end. And so it's not like you go into your labs today and you're going to do this experiment, there's going to be a definite outcome, and you're going to do this write-up, you know how it's going to end. I had no idea what I was going to get myself into. But as a result of this, you learn very important life skills that you're probably not going to learn anywhere else. So you have to learn how to problem solve, since every day is different and every day brings new challenges. Chemicals don't really play by the rules, and so you need to, I guess, learn how to adapt with every situation that comes your way. You have to learn how to multitask, and so in addition to doing research, you also have to take classes, and so you need to be dedicated to both. Also, I like to think of it as a good way for me to think quickly on my feet. I had reactions that didn't go right, they were expensive, my boss was out of town, and you have to think quickly on how you're going to save this reaction so that you don't waste money. So there's a situation where you can think quick on your feet. The discoveries that you make could lead to public presentations and possibly a publication. And so I went on several trips and presented my research at different types of conferences. You get to work in a laboratory with other graduate students and or undergrads. So I went to a smaller liberal arts school and there wasn't any graduate programs around. So I worked with other undergraduate students. And if you were to go to, say,